Hi, welcome to a follow-up video on the Arduino series. In this specific video, we are following up from the potentiometer video. So if you have not watched that video, please watch that before you do this one, because the principles that we're going to use in this particular video are basically follow-ups from there. All right. So in this specific video, we are going to create a light control system that basically turns a light on or off depending on the amount of ambient light. So think about it as, can you turn on a light when it goes dark outside? And for this specifically, we'll be using another special type of resistor called a light dependent resistor. This resistor is a resistor whose resistance changes depending on the amount of light that it's receiving on its surface. Let's get started. All right, so if you remember in our previous video, we talked about a variable resistor. And just to recap, this is the symbol for a variable resistor. You have one connection here, you have another connection here, and then in the middle, you have a connector that then connects somewhere here. This is the variable resistor. Or potentiometer, but it is actually behaving like something called a voltage divider. And a voltage divider is a special type of electronic circuit that basically divides voltage. So if you have 5 volts coming out of here and 0 volts coming out of here, then at any given point, depending on how this thing is rotating, you'll be able to get a variable voltage coming out of here, right? So maybe if it's in the middle, you may be getting 2.5 volts. And if it's somewhere here, you may be getting 0.3 volts. And if it's somewhere here, you may be getting 4.6 volts. Now, if you break this down further, you're going to have a circuit that looks like this. And now what's happening is that you have basically created 2 resistors in series. And at any specific point on this line, you have a resistance value 1, resistance value 2. If it's too close to this side, 1 is smaller than 2. If it's closer to this side, 2 is smaller than 1. But this entire circuit is called a voltage divider. And it's a very common circuit, and you might have learned about it in physics. It's extremely useful in the physics world, in the electronics world, and we're going to see a real-life example of it. Now, if you have a fixed resistor here and a variable resistor here and connect it to the Arduino in a certain way, what's going to happen is that depending on the amount of resistance here, you will be getting a value going into the Arduino board's analog signal, and depending on that value, you can use it to control something else, right? So in the first example we used in the previous video, it was a simple potentiometer. So you could control brightness depending on the position of the potentiometer. But in that case, you're manually changing it. What if you wanted it to be controlled by something that you don't have to monitor all the time, like the sun? So in that case, you would replace one of these with a variable resistor called a light dependent resistor, all right? So in this case, what we are going to do, R1 is a fixed resistor, and R2 is a light dependent resistor. Now the symbol for a light dependent resistor is with arrows showing light. So let's combine the two. So our circuit now is going to have a light dependent resistor and a 10K ohm resistor here, and then this will go to analog 0. This will go to positive 5, and this will go to negative or ground. This is the circuit that we are going to replicate in our Arduino system. All right, let's try it. So this is our existing circuit from the previous video. All right, we have our green wire going into the middle of the into the middle of the variable resistor, and then you have the red wire going to the positive, which is 5V, and then you have the black wire going to the negative, which is ground. So we'll just remove this, throw it away, and then just to give us some space, we will expand and create room for these. So the only thing that has changed is that we have removed our variable resistor and we're going to replace it with our voltage divider circuit. And in this case, this is a 10K resistor, 10,000 ohm resistor. We're going to grab it and put it right there. And then we are going to get this and put it right there. Now, if this is working well and we connect our Arduino code without changing it, the code that we wrote last time, without changing it, we are going to see that now there is a variance in the output going to A1 that is dependent on how much light this LDR is getting. Let's look at our Arduino code. All right, so then if we go to the Arduino board, you'll see that yes, it's receiving some sort of signal from the serial port. Now, is this signal actually coming from the LDR? Let's find out. What happens if I move my hand and close and move it over the light? You'll see it actually changing value, getting dimmer and dimmer, and then if I open it to the full amount of light in the room, it goes to 800. Let's get a source of light, like a torch. So you'll see that as the light increases on the LDR, the value of the serial port increases, and as you remove the light away, the value goes back to normal. Now, this room is very brightly lit because of the studio lights, but as I cover with something, my hand for now, you'll see it go to 0. And if you really, there's a lot of ambient light, but I think there are ways you can darken it. There you go. So when it's fully covered, the amount of light coming in actually goes down all the way to 200. Now, one thing that you have to be really mindful of is this is a very sensitive circuit. So any small interference here, any small misconnection, you might get a lot of, like, if you notice every time I touch something, the value keeps jumping up and down. So you need to make sure that it's actually very well fixed, otherwise your values will keep jumping. If you don't see any difference as you put your hand or put a light, then know that there's something wrong with your circuit. But this is what it should look like. We have an LDR that's going to the positive on the Arduino. We have the center point, the center tap that's going to A0 on the Arduino, and then you have a 10 kilo ohm resistor that's going to ground on the Arduino. You do it like that, it's going to work. The other thing to be mindful of, depending on how you arrange this, depending on whether this LDR is on the left or the right of this circuit, it will increase the value you're getting from the Arduino will increase or decrease depending on the position of this. All right? So if it may be, and this is hypothetical because I haven't tested it yet. Actually, no, we can test it now. If it's on this end, when I cover this, the value reduces. When I increase the light, the value increases. So let's try and swap them and see. What we're going to do is we're going to swap the 10K, and the LDR. Very simple swap. And now, in this case, the more light there is, the lower the value. So if you'll see now it's actually going all the way down to the 60s. Whereas in the other previous swap, more light meant that the value increases. In this case, more light, the value is reducing. Let's cover it again and see. So now it's fully covered, and now you're getting much higher values. So it has basically flipped it around. So again, depending on the position of your LDR, the values will change a certain way. How this is useful is, imagine that you want your lights to go off when it's bright outside, all right? Or you want them to go on when it's bright outside. So it really depends on what you're trying to do. You might want a security system that goes on at a certain time when it gets dark, right? But then goes off when it gets light because it's daylight. But then you might want a system that is the reverse, like something that goes off when it gets to night time. I don't know what that is, but you can figure it out. So just keep in mind that the position of the LDR will determine how your circuit will behave. So let's see a practical demonstration of that by connecting an LED to the same circuit. All right, so now what we're going to do is we're going to get an LED, and then the brightness of this LED will be determined by the amount of light that the LDR is receiving. So what we're going to do is that we want to connect this to pin number 11. It can be one of the PWM pins. Again, if you don't know what a PWM pin is, please review other videos. But what's happening essentially with PWM pins is that it can send a signal that is not digital, but is a sort of approximation of an analog signal. So we're going to put our LED, and then we're going to protect it with a resistor, as always. This resistor is going to come from the negative to the negative end of the LED. So then I get a jumper wire and plug it into pin number 11, and then put it in the other side of the LED. And then the next step is going to be to write code that then says get the value that you're getting out of the green wire, which is basically the variable resistance that's coming from this LDR, and then convert that into a figure that can be used by the LED. Two things to consider here. One is that the range of numbers that's coming out of, the range of values that's coming out of this light sensitive circuit is between 0 and 1024. We looked at it in the previous video. It's through a process called analog to digital conversion. However, the range of values that's coming out of pin number 11, the PWM, is going to be 0 to 25. So we can find a way to map the values, but for today's video, we're just going to do a very simple calculation. If you divide 1024 by 4, you roughly get 256, which will work for us for now. So we're going to just do a very simple division, and that's why you might see somewhere it might say divide by 4, and I will explain. So let's write the code. So this is our code. We have potentiometer pin A0. We are going to also define, and again, this is just purely for the sake of simplicity. We're going to define LED pin as pin number 11. And then we are going to assign pin number 11, which is, in this case is called LED pin. We are going to assign it as an output. All right, so you have pin mode LED pin is an output, right? And then we are going to write an interesting piece of code. Let us assign a variable and say int potentiometer. We're going to call it, we're just going to shorten it, pot value equals 0. So we're creating a variable called port value, which is the value of the potentiometer, and in this case we're giving it an initial value, an integer value of 0. And then what we are going to do is that we are going to say in the loop that the value of port value should be equal to what you get when you analog read the potentiometer pin. So what we're basically saying is that change the value of port value to be whatever you're reading in the analog pin S0, which has been previously been defined as potentiometer pin. Then let's create a new value, a new variable, and call it brightness, and we'll give it a value of 0. And then what we'll say is that brightness should be equal to port value divided by 4. Remember the calculation that we did earlier, the quick calculation? So we're basically saying that in this range of 0 to 1024 that you're getting out of the analog pin number 0, which is the reading from the light dependent resistor, convert that into a range of 0 to 255. And this is a quick and dirty way of converting it by just simply saying divide the whole thing by 4. And then next we shall create an analog write. So then the next step is analog write LED pin, in this case that's pin number 11, and give it the value of brightness. And that's it. Let's upload, see if it works. All right, so we have our code that's working. If it's all working well, then the brightness of this should be dependent on how much light the LED is receiving. So in order to make this a little bit more visible, I just created a really long cable so that we are able to see this clearly without this being a distraction. So what we're going to do is it's just a jumper wire that's been extended. And what we're going to do is get the LDR, stick it here. And the goal is that you should be able to see, and what I'll be doing is basically like covering it there, and you see it go brighter, right? So if this is your sun that's rising and then gets to daylight in the morning, you can create a value where your LED goes completely off. Or if it's full darkness, then your LED is fully bright. And that's it. Very simple. Obviously, you can tweak the circuit so that it's completely off or completely on. That's really dependent on what you're trying to do. But for now, we are basically increasing the brightness depending on the amount of light that this is receiving. And there are very many ways you can apply a circuit like this. It's really up to how creative you want to be. Yeah, so that is a very simple demonstration of how to use variable resistors in separate scenarios. So in this specific case, we used a variable resistor, special type of variable resistor called a light dependent resistor to control another light source. It's a very simple way, a very simple demonstration of how you can use Arduino systems to get information from one place and use it to control something else. And in this case, we're getting information from the environment. So this LDR is a special type of electronic device called a sensor, which is basically something that collects information in the form of an output, sends that to a system, and then the system processes that information and uses it for something else. A sensor can be a light sensor, a sound sensor, a visual sensor, humidity sensor, oxygen level sensor, carbon dioxide sensor, etc. And sensors come in all sorts of shapes and sizes, but the point is that you are able to use an Arduino system to get information from a sensor, process that information, and then use it for something else. So I hope this has been helpful. See you in the next video.